Hey, this is Christian. So last time we continued solving algorithm problems. I solved one problem off camera. I was actually trying to record and Loom ended up crashing. But check it. So the warm-up section, they're all complete. We're good to go. Now that we're all nice and warmed up, we'll go on to the next challenge. It's called grading students. Round students' grades according to Sam's rule. Alright, let's check this out. Okay, the grade range is between 0 and 100. Any grade less than 40 is a failing grade. That's not bad. If the difference between the grade and the next multiple of 5 is less than 3, round grade up to the next multiple of 5. If the value of the grade is less than 38, no rounding occurs, as the result will still be a failing grade. Okay, that's pretty easy to understand. So let's see some examples to better understand this. Round it up to 5. This one stays. 40 goes down. Oh no, it goes up. Sorry. So if it's for each interval of 5, if it's more than halfway, if it's more than 3, then it'll be rounded up. If not, it'll just remain the same. Well, that's not true. Well, okay. So if it's less than 40, they fail. So since this one will be rounded up to 35, it just stays since it'll still be a failing grade. This one they round them up, so he passed. You got a C here. Oh no, wait. A D, I guess. And then 75, yeah, this one was rounded up. Okay. Okay, makes sense. Yeah, there's further explanation, but we already understand it for the most part. So yeah, the output is just the rounded input. Okay, complete the function, grading students. The function is expected to return an integer array. Okay, so that'll be pretty easy. We'll set the array to the number of grades that are being inputted, and then the function accepts integer array grades as a parameter. So yeah, down here it probably has it accepts it. It creates an array from the inputs that it preset. Okay, so we'll do the classic setup. Kind of write out what we're gonna do. So since we're returning a new list, what we'll do is we'll create a variable for the rounded, well, we'll call it Sam's grades. Sam's grades, which will be an array, or sorry, a list. And then we'll iterate through the inputs. We'll have an if statement. That finds the remainder, divides it by 5 and finds the remainder. So it'll be let's write it like this. Check if, capitalize it so we know it's an if statement. Checks if checks if it needs to be rounded up. And I'll write a little hint for myself, %5, because then that'll give us the remainder. And then we'll return sans grades. That's it. We're done, because I'm guessing it'll have a statement down there that prints it. So let's initialize our new list. Sans grades equals new list. We'll go with grades dot size, I think. I haven't looked over that class since the last time we used it. I had never used it before, so that was my first time using this class, or this object. I don't even know what it's called, but one of those two. So we'll iterate through each of the lists. We'll start at 0, as long as I is less than the grades dot size, and we'll iterate through I. Let's close up this for loop. Now we'll check. I'm trying to follow these comments a little bit better. If let's see if this works. Grades dot index of I %5. We should actually do this outside. Okay. I don't really like abbreviating. I guess it makes sense in some cases, but I usually end up forgetting what the variable, what it stood for. So I just like writing out the word, especially for these short programs. Maybe if I were writing something more extensive, I would shorten it, but for these purposes, it's just a lot easier for me to quickly remember, especially since I'm out of practice. Remainder, we'll copy this. I think it's index at, actually, not index of. %5. So we'll get the remainder. If the remainder is greater than or equal to 3, okay, I have an idea. So we have the remainder, so we'll add it to, okay, check this out. It's gonna be cool. How do you modify? I don't know how to modify the value at this index. I'm gonna have to look at the list class methods Java. Perfect. So last time I was recording and my computer crashed when I opened to look something up. Loom froze, and then I accidentally made this full screen. So this overlaps everything I open, and when I made it full screen, I couldn't interact with the task manager. So I was trying to shut off Loom, and I don't know, after a while I just kept trying to close from the side over here, and eventually it closed, but it took a long time, and I lost all the footage as well. Okay, so we're not adding, we're modifying one of the index .get. Ooh, I think we might need to use .get .set. Okay, set is the index and then the element. Okay, that's actually what we need. Replace sort, that's too much. Okay. So this is we're gonna use .set. I don't know if index add is even in here. I didn't see it. No, it doesn't look like it. So we're gonna use .get is what we need. .get I. Does it accept a parameter of index? It does. Awesome. Okay. It's .get I. We'll do that. Sans grades .set. And then we'll do the index of I, and then the number is going to be it's going to be grades dot get I. It's not going to be plus the remainder, it's going to be 5 minus the remainder. Okay, so this is a little confusing. So this get set statement accepts the index, and then it also accepts the element. Let me see if I can find it. Here it is. Set. So it accepts the index, which is going to be I, and the element, which is an integer, which is what we're setting here. So we don't want to just, we need to find a way to round it. There's probably a round function or a round method that I can use within the Java class, but that's how I'm going to do it. I'm going to do grades.getI, so we'll get the value of the grade, and we're going to add it to 5 minus the remainder. So we'll use an example. 5 minus the remainder, remember that. So 73. So when you do %5, the remainder is going to be 3, right? Because 70 divides evenly into 5 how many times? I can't think. 12 times. No, sorry, 14 times. Is that right? Yeah, 14 times. So there's going to be 3 left that doesn't divide evenly into 5. So that's going to be the remainder. But if we add the remainder to the original grade in order to round it, it's going to be too high. It's going to give us 76. So instead you do 5 minus the remainder. So that'll give us 2, so that'll give us an even round. So in the case that this was 74, the remainder would be 4, and then 5 minus 4 is 1, which would still round perfectly to 75. Okay, so we're adding the element at grades.get, and we're setting it in Sam's grades, right? So in the case that it's not, if the remainder is not greater than or equal to 3, we'll do nothing. It'll stay the same. So, okay, so we'll set another value to the grade. Actually, I'll do it like this. I'm gonna switch these two around so then I can just use the call this current grade. Okay, this will give us the remainder. Remainder is greater than or equal to 3. So we don't need to, yeah, we do need that, but we don't need this. We just use the current grade. Excuse me. What was I going for again? Okay, so what I'm going to do instead is I'm going to get the current grade minus equals the 5 minus the remainder instead. And then out here, I'll do Sam's grade dot set to I I comma current grade. So that way we don't have to call the set statement twice. We just set the current grade to, oops, I'm sorry, it's plus equals to whatever it's being rounded to. This will only be changed if the remainder is greater than or equal to 3, meaning it needs to be rounded. In the case that it's 2, 1, or 0, then it'll just enter the current grade, right? And then finally, we'll just return Sam's grade. Boom. Easy. I probably should have checked over my work, but that's okay. So if for some reason this new statement didn't work, yeah, these won't work. Alright, so do I have to do the integer thing too? Okay, maybe this will give us an example of how to initialize the list statement. Yeah, string val arrays dot as list, and then vowels. Yeah, new array list. Oh, is it array list? Let's try it. I don't know if that's only for string though. That's the only thing I'm worried about. So he doesn't initialize the, just leaves it closed and then that closed. Let's see another one. This one doesn't set the size, which I think is kind of strange. Actually, I could just use the dot add. I don't need to set anything because we're not actually changing the values because it's a new array. So if I did this array list like that, let's check it to see if that works. No. Sam's grade dot add. Yeah, what's wrong with that? Should I set it to integer? Will that change anything? Oh, it's Sam's grade. Oh, that's what I wrote. Sam's grades. Gosh. I need to find a more consistent way to name these variables. Okay, Sam's grade. Again. Okay, so see what we got. 75. That looks good, good, good. Oh, that one's a failing grade. Okay. So we forgot to create a case for the failing grade. Alright, so we'll do and the current grade is greater than or equal to 40. So that should fix it. So that way it won't modify the remainder. So we still got it wrong. What are we getting? 33 looks fine. Oh, okay. We'll put 38 instead. Because we have the option to round up on 38. Yeah, that's the last possible case to round up. See? Alright, very nice. That should be good. Alright, so first problem complete. I'd like to thank all my fans for their unconditional support through this hard time. Congratulations, we earned our second star. I don't really know when we earned our first star, maybe when we signed up, but it's something. They got some nice confetti. Alright, so I think we can do one more. That one was not bad at all. Alright, let's go. Alright, so Sam again. If this problem ends up being hard, Sam and I are not going to be friends. Whoa, they even have a picture in this one. Okay, Sam's house is an apple tree and an orange tree that yield an abundance of fruit. In the diagram below, the red region denotes his house. Okay, so that's his house. It's kind of small, you know, a little flat. Where S is the starting point and T is the end point. Okay, the apple tree is to the left of the house and the orange tree is to the right. You can assume the trees are located on a single point where the apple tree is at point A and the orange tree is at point B. Okay. When a fruit falls from a tree, it lands d units of distance from the tree of origin along the x-axis. Alright? Glad it has this picture, because I would have a really hard time mapping this out in my brain. A negative value of d means the fruit fell d units to the left, positive value is right, and a positive value means it falls d units to the right. Okay. Given the value of d for m apples, okay, dm's, and n oranges, determine how many apples and oranges will fall in Sam's house. Okay. So they're just going to give us the values. Oh, that's not bad. -4. Okay. So apples are A. The apple tree is A. So that's a point we have to keep track of. Okay, I'm going to write this down. A equals apple tree. B equals orange tree. It's going to be in my little guide to help me stay on track. So then S is the left side of the house. I'm going to draw an arrow between A and S because they're going to be close. And then B and T. T is the right side of the house. Okay. So then D applies to both the apple and orange tree. D is distance. The fruit fell from the tree. Okay. And then M is going to be the number of apples. And then N is going to be number of oranges. Okay. Alright, cool. So if the house is between 7 and 10, an apple tree is located at 4. So they're all along the same x-axis. So it's 3 units away from the house. And the orange tree is at 12, which is 2 units away from the house. Probably a pretty simple way is going to be to have the difference from the tree to the house and any positive values. For this one, any positive values, and this one, any negative values. Because the D units, yeah, it applies to both. So D is negative if it falls to the left at any point from either tree. Okay? Alright. Yep. So M equals 3, N equals 3, so those two numbers can be different. We'll probably run 2 different arrays. Or we can run both arrays simultaneously until I don't want to accidentally reach out of bounds on one of the arrays though. Oh, I had a cheat sheet right here. Man. Alright, cool. So you can go up to, what is that? 100,000? Wow. It's a lot of fruit. Okay, sample input, 711. So I'm guessing 7 is I don't actually know what these numbers represent. This is important. Okay, 711 The first integer, the number of apples that fall in Sam's house. Okay, so 7. Second integer, the number of oranges that fall in Sam's house. Oh, this is the output. What about the input? The first line contains 2 space separated integers, s and t. So I'm gonna go st. Second line ab, and then mn. So then 3 is the m array. Or no, it's the array of apples, so it's A to M, and then B goes from 0 to n minus 1. Okay, cool. Alright. Should be not bad, so right side of the house is at 7. The apple tree's at 5. So if anything falls positive 3 or more, it'll hit the house. Should be, wait, yeah, positive 3 or more, right? No, positive 2 or more. Why is it 1 and 1? Number of apples, number of oranges. Okay, so we have 1 apple and it's -6 is gonna hit 1 orange. Okay. Yeah, see, okay. 5 minus 2, 3. Oh, okay, that's actually a lot easier than I thought. Since it's subtracting, it gets closer to the house. And since it's adding, it gets closer to the house. So either way, it'll be simple to find. Alright, cool. So now, I understand the problem, more or less. We've taken a ton of integers, wow. Alright, so let's do the classic. Okay, so we're gonna need variables for we call it apples. Hit the house. Okay, we're gonna iterate. Let's just start capitalizing these so it's more clear. Iterate through. Apple and orange arrays. Ifs. To check if the fruit hits the house. Okay, and then we'll return. I'll just print them, right? Yeah. Print put bars. I'll put apples first. Okay, so there we go. So we'll go int apples. I'll put a hit, and then we'll put int. I'll put o hit, because I'm gonna get confused. I already know. So we'll make a loop. Let's follow the outline. For goodness sake. Alright, so I don't know if I should make 2 separate loops or try to be more efficient, and So make an if statement out here to check int, call this length, equals, we'll put it to 0 right now. Well, no, that's not smart. Yeah, we'll put it 0 for now. Go int length. I'll actually put it to -1 because we know that's impossible in this situation. Although if we were making test cases, we should probably test for it. If m is greater than, actually we'll set it to m initially, and then we'll go if the n is greater than the length, then the n equals the length. There's probably a better way to do that, but that's fine for now. So then we'll do less than the length. Okay, so we're gonna be iterating through. So first we're gonna check if I is greater than n. Should be greater than or equal to. Not just greater than. Yeah, well. N minus 1. Because it will go to I. Yeah, we'll do it like that. Let's try it. Do it. I don't know if this is a smart move. Would it be better to do 2 different loops or to have 1 loop that does everything? Okay, we'll try it. We'll try it out. We'll just do a check for, yeah, okay, this will be fine. We'll go M. Is that what it's called? No, it's called apples. Do another statement. If apples at index I plus, so what is apple tree plus A? Let's set it out here actually. We'll call it XA for X apples. Call it X app. I like that better. Apples of I plus A, so this determines the location of the apple. Because this is the distance D, we have to add it to the location it fell from. So if the X app is greater than or equal to S, and not just like that, it should hit the house. Oh, what if it goes over? It can go over the house. Is that possible? I think it can, honestly. We'll assume that it can. It's less than or equal to T. Then app a hit plus plus. So that adds 1 to the apple hit count. So I'm always gonna have to do this, so we'll do this one outside here. So then we'll do another one that only tested if I is less than or equal to n minus 1. No, just less than 1. Yeah, we'll do it like this. If I is less than n, I'll put a little comma here. Tested for larger array, makes sure the loop doesn't try to access index outside of the array. Okay, so if I is less than n, then we'll do the same thing but for before the oranges, sorry. So copy this in, change this to oranges. Plus orange. OG, I like that better. O B G Y N. Okay, so an issue I can see happening is these right here. If I initialize this in here, it's not gonna let me print it. I guess I could print it at the end, huh? No, it's okay, it's okay. Yeah, that should be fine. So then at the end here, we print everything. So I'll print it in these statements. No, we print it at the end, huh? Yeah. If to check if the fruit hits the house, so we'll do this up here. Okay, and then print the variables. Okay, we'll copy this. We'll do A hit, and we'll do O hit. Okay, quick run through. Alright, so we initialized a hit counter, we found the length, we compared to make sure whichever fruit falls more is the number of times the iterator goes. So in this case, I have to do if I is less than call this more fruit, and then we'll call this less fruit. If n is greater than more fruit, I do it like this. I kind of don't like it. Confuses me when I do things outside and then I do something different. Like if I pre-initialize these to something and then I switch it around, it's a little bit more confusing than if I write the full if-else statement. Okay. So this will be, I don't know, a little easier to understand. If m is greater than n, then we'll do this. And then else, I know what you must be thinking, what about 0? Or what if they're equal? If they're equal, it doesn't matter which one is which. So it's okay to set n to more fruit, and then I can't spell m to less fruit, because they're both gonna stop at the same spot. So I'm gonna change this here, more fruit, and then we'll do this, I is less than less fruit. That looks weird, XOG. No, yeah, it looks good. It should work. If OG is greater than or equal to S, but less than or equal to T. Yep, looks good. Okay, boom. I wait the day I do that, and it compiles. If m is less than n, okay, there's no m and there's no n. What did it use instead? What is m and n? Ugh. Oh, it's the length, so it'll be apples.length. This is oranges.length. And then vice versa over here. Oops. No. Alright, cool. The good news is I wrote a really good explanation of the variables from the problem. Bad news is I didn't pay attention to the changes made. Okay, so it works. First try. Let's go. Here we go. We have a few that did not work. So just a quick review before I try to unlock some of these. So a few worked and a few didn't, meaning there are certain situations where. So one thing I can think of is one of the cases I blocked is if it went over the house. So say for example, so say this is at 5 and this is at 8, and then this is at 10. So if this apple traveled 6 distance, it would hit 11, which is over the house. But I'm not sure if it accounted for that. Let's see. For example, it's between 7 and 10. B12, there are M, 3, and 3. Adding each apple's distance to the position of the tree, they land at blah blah blah. Oranges land at blah blah. 1 and 2, so 1, 2, okay. So it doesn't give any scenarios where it goes over. But it should make sense. B, it's got to be less than that. It's got to be less than that. Okay. Let's see if we can find anything else that would prevent us from being right. Less fruit. So this is the length. So that way it won't access an index that is too big. So B was the position of the orange tree. That is correct. We do want to be adding that. So if the x-axis, the orange, is greater than or equal to S. Okay, so if it were 5, or if it were 7, and this were 8, that'd be fine. And it's got to be less than or equal to T. So if it's 15, it's too far. So it looks pretty okay. I can't see anything inherently wrong with it. Alright, so let's unlock one of these cases. Oh my gosh. Wow. So we have some pretty huge numbers. Is that my output? Oh, that's the input. Whoa. That's kind of a lot. was hoping to test it to see what would happen, but let's see if it lets me download it. So then I can just copy paste it. This one's gonna be huge though. Look at this. Oh my gosh. I didn't realize the test cases were this complex. Oh my god. Okay, so one thing I could possibly see being wrong is, let's see what's the max value of an integer. No one would have told me that I should use a long. I could try to use a long just in case, but that was huge. No, we should be able to tell from here. So the max value is 100,000. Int max value Java. 1, 2, 3. 1, 2, 3. Yeah, it can hold way more. So that shouldn't be the issue. That test case was crazy though. Did you see that? I want to see one that's smaller though. Runtime error. Oh. Wait. So if it's a runtime error, does that mean it's taking too long? This is the expected output. Let me see if I can copy this whole thing. Okay, I copied it. I'm gonna write down the expected output, 28 and 2966. Alright, let's check this out. I wonder if this tiny text box will let me. Oh, my computer's running. Well, let's see if it runs. Should not exceed 50 kilobytes. Oh gosh. Okay, so let's see. Java. Okay, that was not very helpful. Maybe, yeah. This is the only other thing I could see maybe being wrong. I'll initialize these right outside here, so it's not confusing. So we'll set this to 0. Actually, we'll do the apple first, for the sake of consistency. Yeah, I could have just done this outside. Wait. Yeah, technically, I don't know if this is a good idea, but yeah, it's fine, because in each of these we're changing it as soon as we go in. Okay, so let's try again. So this time we also got all 3 is one of the ones we already tested for. Runtime error. Success. Alright. So, since we finished the warm-ups, they definitely stepped it up a few notches. This will be an interesting adventure. Maybe I should have saved this for the next video, but I think we'll be fine. Okay, so the apple's at I plus A. Oh, okay, I already see what's wrong. So, in some cases, I think this might be our best bet. Check it out. Alright, so we're gonna have to be testing to make sure we don't exceed either length of each array. So yeah. Okay. We'll do it like this. We'll do apples dot length here. Then we have to do oranges dot length. So we don't need a value for less fruit anymore, which is fine. So apples is greater, then oranges is greater. Boom, boom. We gotta complete this if statement. I know this is very disorganized, but it's coming together. Check it out. Okay. Tab this. Tab that. Tab this. Okay. So you don't need these. Alright. So we cleaned it up to make sure that if it reaches outside of, if it goes outside of these array lengths, that it won't be testing for incorrect, or it won't be trying to get indices that are outside of the arrays. So it worked. Check it. Too easy. Alright, so this practice session went a lot smoother than the previous ones. You know, honestly, I was the past how many videos has it been? 4 or 5? I struggled a lot, to be honest. I would watch myself and actually listen to some of the audio as well, and I was noticing I didn't talk a lot. I was noticing that, I don't know, I was just making dumb mistakes, and I wasn't really explaining and talking through what I was doing. So I try to do that a lot more here, and you know, honestly, this video was a big confidence boost. The second problem was a lot more, I don't know, it felt, the way they worded the problem felt a lot lengthier than most, so it took me a little while to understand. I got kind of scared when I saw it, but I worked through it. You know, I broke it down, and it failed the first couple of times, and I saw the size of the test cases was enormous, and I got scared again. I didn't think I was going to be able to solve it, but you know what, I just kept going. I kept breaking down. I found one mistake after the other, and you know what, we prospered. We succeeded. And I don't know, I'm very grateful, and I'm looking forward to see how much more I will improve in the coming months. Alright guys, catch you all later. Thanks for stopping by.